Hi, everyone. Welcome to the Consultia Podcast. Today, we have the pleasure to have Stamatis with us. Hi, Stama.
Hi, Salvo. Thanks for having me.
How are you? Good?
I'm fine, thanks. How are you?
Nice. Not too bad. Thank you. So thanks for attending the podcast. And I prepare, 4 questions for you, a technical question to discuss of one of your papers, successful paper that you published in CVPR 2018. I will crack on with the first question, if you don't mind.
Yeah.
We are, curious. Computer vision is one of the hottest topic in AI. Can you tell us about, your line of research? Tell us about more.
Yeah. So actually, since I started my PhD in 2004 in the National Technical University of Athens, my research has been mostly revolving around the inverse imaging problems. So just to explain you what I mean by this term, I will give you an example and I think it will be clear. So imagine that you have a sensing device. Let's say this is a smartphone camera or a MRI scanner. Okay. So, and you have an excitation source. And based on this excitation source, you are collecting a set of measurements from an object that you want to image. Okay. So now, you have in your disposal this set of measurements, and also you have a physical model. Essentially, this is a way to mathematically relate the measurement that you have and the object you wish to image. So now, the main problem.
Myself, just having a look at
Can you hear me now?
Yeah, but I was hearing background noise, sorry.
Okay, sorry, yeah.
Should we start from the beginning or?
No, it's fine.
Okay. Yeah, so now, because also of the limitations you have with the imaging devices, the measurements you get, actually, they suffer from several types of distortion. So now the goal is based on these measurements and your physical model to be able to infer the object that ideally you would like to image, right? So this kind of process is called an inverse problem because you have a forward model which explains how my measurements were collected, and based on that, you want to go back to the cause of these measurements.
Sure, and I assume this is a complex approach. So what kind of techniques do you use to deal, with the problems that will arise in your research areas?
Yeah, actually, you are right that these problems are quite complex in the sense that, unfortunately, in practice, this kind of information you have is not enough by itself to be able to do this kind of inversion. So you need to rely on additional prior knowledge you have. And there are many ways how to express this kind of prior information. And there are techniques from several different areas, like from areas from statistics, calculus of variation, and machine learning. In my career, actually, personally, I have been using techniques from all these fields. But nowadays, I have been mostly working with deep learning techniques, but I also try to incorporate some principles from image reconstruction and optimization techniques into the deep learning network that I'm developing.
Nice. Okay. So you have a papers that you published that we want to discuss. I think you are the single author in this paper.
Yes,
and it's a paper that you publish while it's your experience at Caltech University in Russia. And the paper is a CVPR 2018 and is the Universal Denoising Networks, a novel combination network architecture for image denoising. present us this paper and why this paper has been so successful.
Yes, actually, you're right. So I published this paper when I was an assistant professor at Consultia University in Moscow. And this is a very good example of how you can combine techniques from different fields. Because we know right now, I mean, deep learning is a very hot area. And mainly the reason is that techniques that they rely on deep learning, they tend to have very good performance and they overperform in comparison to previous classical techniques. But you know, one of the main issues is that if you want to have a production-ready deep learning system, you need also to make it compact with a small memory footprint if you want to use it on devices that they have limited capabilities like smartphones. So in order to be able to maintain the performance of your deep learning network and at the same time somehow compress it, make it like smaller, you need also to be able to fuse information to your network. So the more information you give to your network, the less you need to have it like a deep network. So this was actually my motivation, and mainly because I have an extensive background on classical techniques about inverse problems, as I mentioned before. So I tried like to marry these two areas where I used my prior expertise and tried to develop some networks that take into account information which will help them to be like smaller and still be very effective. So,
I see.
and what I mean by that, actually, just to make it a little bit more clear, in classical denoising technique, there are two main properties that they are extensively used. One is the local regularity of the image, in the sense that mostly all the natural images that we see in around us, they tend to be mostly smooth with some transitions edges. So typically, you have like an image which has some smooth intensity, and then you have some variations which correspond to an edge of your image. So this is called the local regularity principle. And another one is the non-local self-similarity principle, which implies that if you see a picture, actually there are some structural patterns that they repeat themselves in the image. I will give you a very simple. If you will see it has a lot of leaves, right? So this pattern repeats itself. So actually, it makes sense to use this redundancy, the redundant information, to be able to separate the noise from the actual signal. And actually, this is the whole purpose of denoising, to try to figure out how I can represent my measurements in a space where the noise and the signal itself can be easily separated. So I relied on these principles, and I designed networks that they try to model these principles in a very effective way.
Interesting. It's an interesting problem actually, and last, one of the last question I wanted to ask you is, the importance of image denoising, in a low-level computer vision.
Yeah, so actually image denoising is a very important problem, not only as a standalone application, because of course, I mean, in many cases you have some images that they are noisy or videos that they are noisy, and you need to process them. But image denoising is also important in two other aspects. First, the first aspect is that you need to pre-process your data if you want to further use them for some other application. For example, imagine that you want to have like a face recognition system. So currently, I mean, all the deep learning systems that exist in the literature, they make the assumption that the image they have is of high quality. right? But in practice, this might not be the case. So in order to be able to make these systems perform the same way as they have been trained to, you need to also to provide high quality images. So denoising can be a part before feeding your data to this classifier, pre-process them. And the other aspect that it's really important for and makes actually image denoising a very important application is that, as I mentioned before, when we are discussing about inverse problems, image denoising is just one particular problem. Actually, it's one of the most simple problems. But if you want to try to solve more difficult inverse problems, for example, one such problem would be in painting. So you have your image and there are some occluded areas and you want to be able to recover the missing information. Or the blurring, you have blur in your image and you want to remove it. So actually the whole pipeline to solve these problems can be split in a process where you need to do also a denoising. So denoising actually appears in many different problems as a sub problem. That's why if you can solve efficiently denoising, you can use this denoiser to solve also more generic problems. So this is why actually image denoising is very important in the low-level computer vision.
And look, thanks for giving us, this highlight, about your papers and about your research topic. I have, not really a question. It's probably an advice. Many companies, I've worked with global organizations mainly, and many of them asking about, CVPR, ICCV, ECCV, first author, last author. What is your what's your thoughts? The latest, papers. Have you seen something interesting, or where do you see the research going, especially from when you started, which was, a long ago?
Yeah. So actually, if you ask me, it's a very difficult thing to identify whether a candidate is good only from how many publications it has, or it's very challenging because there might be cases where you have someone that has like a lot of publications, but actually in every publication there is only a minor difference between the previous publication he had. So it's not really easy to say. So I don't think that it matters as much as people might think how many publications you have. And in my career, actually, my whole goal was not to create a lot of publications, but to do things that I enjoy. And later on, I would be happy to read the result. I would feel like proud of my work. Not like how many I have, but if I can have like just a few, but I will feel like I contributed to the advancement of the field. So so it's a bit difficult task. But actually, regarding the second part of your question, I know that let's discuss better for the deep learning area. In the beginning, like how to play that the field emerged, a lot of people started following the principles of deep learning and trying to
get these people on board.
new results. There have been a lot of publications, and actually not a lot of them stuck out. And now I think there is a trend in the field where we are trying to figure out how can we make systems equally to perform equally well, but to be more robust, to have more information about the problem, because so far there has been a tendency that, okay, whatever problem I have, I will just have a huge network, and the network will learn itself automatically. But actually, this doesn't work in practice. So you need to carefully think how to design your network, how you are going to train it, what kind of information will be important to give to your network. So I think there is a turn right now about techniques that they try also to use experience from papers that they have been published before deep learning era. Because there have been brilliant people doing a lot of very nice things, and it would be completely stupid to forget about that and just rely on building like huge networks and expecting that this will be the end of the problem.
Interesting. And a lot of people in the computer vision area. There is any specific professor or any specific paper that you would like to suggest or advise to, I don't know, take input to publish something new for, I don't know, maybe a PhD guys, for example?
Actually, there are a lot of great people working in the field. So it wouldn't be easy just to choose one over the other. So actually, there are a lot of groups, and actually not only in academia, but there are also very strong groups in industry. For example, Google and Facebook, they have really great people working there. So actually, for a PhD student, what I would suggest is, first of all, like, choose what kind of problems he feels that it's really interesting, and then based on that, I mean, you can start with like one paper that is highly cited, which means that a lot of people trust the results, and it seems to be like a good paper. And based on that, follow all the references and try to build like your knowledge about the problem. So at least this is what I did in my PhD. I was always starting from like a really good paper, and then based on that and on the references of the paper itself, I was like building my background on the problem. So I think it worked for me, but I think it's a good approach.
Thank you, Stama. Do you want to mention something, or do you want to ask something about?
Yeah, actually, I want to ask because I know that Consultia right now has been one of the top suppliers of big technology companies in the areas of AI, and I wanted to ask, I mean, how did you manage to do that? I mean, it would be very interesting also to.
I mean, question, because people have the mindset that a recruiter, it's a person who matching a job spec with a candidate, right? So we don't do that. We tried. We work very close with the academia. I collaborate a lot with Professor Greg Slabau at Queensland University, or I support other, professor from Oxford University, for example. And how I managed to do that, I guess, is probably try to think outside the box, try to understand, do a lot of research myself, understand, talk about AI. I think probably this is what, has made us successful, really. As you said, we work with many global organizations, and we successfully support them. We established a very good relationship with postdoc PhD guys, and I guess we are credible, and the people trust us. I think this is our success talks for ourselves.
And another thing that I was wondering, I know that 2020 has been a very tough year due to the pandemic. So has this affected your company, and how did you manage to overcome all the difficulties?
So again, very interesting question, Stama. So we actually double in size. We haven't made anyone redundant in our office. Actually, we opened one office in Argentina. How we overcome this? I guess we are a boutique. So we want to focus in niche market and become the specialist of that market. So as many customer, they have the preferred supplier list. We have our preferred customer list, and we want to work with customers who value what we do. And Consultia has been running for 15 years, and we want to work with people who believe in our mission and the people who believe in what we do. And of course, we will offer a state of the art of recruitment.
And my final question is that I know that, I mentioned also that due to the pandemic, the situation is a bit tough. How has this affected, in general, the job market? And what would your advice for someone that is on the job market and is looking for opportunities? What would be your...
Big names as Facebook, Google, they've been hiring, of course. It's getting probably more difficult to get into these companies. And one of the main challenge, I won't say problem, one of the main challenge is that, for example, PhD people, they want to, keep doing research, for example, and continue to publish paper, for instance. That makes sense. Many companies, though, they won't pay you, a six-figure salary just to publish paper. So one of the challenge we facing every day is that many companies now, especially in this pandemic, they want to they are more product driven. So many people they don't want to be product driven because it's mainly focused on engineering, for instance, not so much research. Probably one of the advice I would say is really, really understand, what you want, and talk with people, talk with experienced recruiters, talk with specialists, and get some career advice. We had a brilliant quarter. We placed only this month 9 people, all of them PhD to global organization. And some of them, for example, they leave global companies to join other global companies. So for good people, the market is always active. I guess probably it's really to understand what you want to do, where do you see yourself. If you want to pursue a career in academia, why is important to keep publishing papers rather than focus on product. And I guess it's something that me and you discuss about these things a lot, especially when we met back in March, February, before the pandemic. And it's it's a very active market, I would say.
Yeah.
No.
Sure.
Yeah. So look, thank you, Stama, for your time. Thank you very much, and thanks to everyone who will listen to the podcast. If you have any question about the papers, please reach out to Stama, or if you looking for general career advice, or if you would like to know more about Consultia and what I'm doing with my team, get in touch with me. And I would say thank you very much, Stama, and I love to talk to you, and nice one. Thank you.
Bye.
Bye.